Let's take a look at a live example. I have some emails downloaded here. I'm going to remove them, and let's take a look at the repository first, right? We have a program, and the program definitely has our circuit, right? You compile the circuit, and it compiles down to an ELF file, an executable linked format file, but you need to run cargo proof build. You can see that there is an ELF compilation here, RISC v32 succinct zkevm ELF. That is what the program compiled down into. Then we talk about the script. The script itself, the main one is network prover rs. This is of course our core script which will run the and create the proof on the prover network. More about that later, right? And then we have our tooling file, which basically has the IMAP extract file, which can extract emails from a particular domain from and basically download it to our local repository, right? This is maybe, let's say, what will be the simulation within the TE environment. There's also credentials.json. I'm going to keep that private, but it's basically right now just generated with the email address and the passkey. Later on in the TE, it can be done via OAuth, right? So let's take a look at, let's download some of the emails, right? So we will use the command sort of which will be python imap extract py, and then from the domain amazon.com, if you remember the dkim header, and then of course how many hours are you actually wanting to filter for. Let's actually take a look at the email itself. As you can see, it's from amazon.com, right, and signed by amazon.com, as you can see. And then this is the product name, there is the product pricing 548, and then the order number itself, right? As you can see that every Amazon invoice will have a very standard script, so we can trust the process, right? As you can see that it downloaded all the emails from amazon.com within the past 24 hours. Of course we can make this more sort of make it more add more granularity, so that it only, let's say, downloads email for orders. As you can see right now, it was a password reset email, a revision to the order itself. But let's take a look at the email itself, right? Let's take a look at the test regular expressions. We have our imperialism email, sort of the order that I had placed. As you can see, there's all kinds of sort of information, data about the DKIM signature. As you can see that it's created from the domain amazon.com, and then there's a domain amazon.ses.com, and then as you can see that it follows the same format that I showed you in the original email. We have the order number, and then we have the total, right? 548 USD. So let's generate the proof for this. As you can see that right now the command is that it's over the network. We have a network private key, an RPC URL, and then from domain. This is very important. Which DKIM header are you sort of mentioning? And then we have, of course, have the proof system, and then the email path, the regular expression, which is basically the format of the email. Go back to the earlier email that I showed, and then we can make a few changes here. It says 2025 310, that's our date, and then it's when the it was downloaded, 1554 amazon.com, and then EML Yash. So as you can see, there was a pattern which was matched. There was a DKIM header which was found for amazon.com. We found a selector for it. Then it is attempting to fetch DKIM key from the DNS, remember the public key, and it's going to choose the selector and then the domain name, domain key, and from the domain name, right? Then it's going to generate the proof, send it over to the prover network. As you can see, it's requesting a proof right now. It says it create in we have the transaction hash here. Let's take a look at if we can find it in the network prover. We have network.succinct.xyz, which will have information about the proof which is being generated, and also it will have a it will have an artifact which will be a downloadable proof as well. We can of course download the proof locally, um, right? We can search it via proof, I guess. Yes, as you can see, we have our proof request. It is a PLONK proof as it's assigned right now, and you can see the cost that it took to generate the proof, right? When it comes to settling the proof on chain, we can also verify the proof on chain using succinct precompiles, which PIS has already done, um, and he has been able to settle the verification key, the prover, public parameters, and the proof itself, so everybody can verify the proof on their own. As you can see, it is still assigned right now. We can wait for it to finish. Proof request assigned, proving. um, let's just wait a little bit. This takes some time. Okay, it is definitely taking some time. It's mostly because of the proof size. So feel free to skip to the end of the video, where I will be able to show you the status of the proof which was generated. How about this? Let's try to generate another proof, but this time let it be a GROTH16 proof. That would be an exciting thing to try out. As you can see, it's the same exact thing, except for the fact that I mentioned GROTH16 here. Maybe I need to get my Docker running as well, just in case. Yes, I have my doc. So let's check if something. It's still proving. It can take time. As you can see now, it is using GROTH16. Created request. Let's check it out in the network prover again. Oh, this was fulfilled. This was our earlier PLONK proof. Let's go to request, network succinct. Let's search for this request. Yes, we can see a GROTH16 has been assigned as well, and you can see the cost for it. So let's check our terminal. So yes, proof verified successfully. Yes, and then it was saved locally as well. Proof saved locally. So yep, that's pretty much it. And yeah, thank you for watching.